Okay, 7.3, we are proving that quadrilaterals are parallelograms. We're not starting with a parallelogram and proving it. We are starting with a quadrilateral and proving that quadrilateral is a parallelogram. Okay? Again, we're going to start in GeoGebra. We have to construct a quadrilateral whose opposite sides are congruent. Okay, so construct a quadrilateral whose sides are congruent. Let's just call the point. Let's call it -4, 1. And a point at 2, 1. Okay, so we're at -4, -1, and we are at 2, 1. Okay, now we need a segment between A and B. What do I have to do? Part A, it says the opposite sides have to be congruent in my quadrilateral. Okay, so if I make another point, let's call point C. Let's call point C at, let's go down here, at -5, -3. Okay. How do I make a segment that is the same length as AB and in the same direction? Because it has to be congruent, right? Same length, same size, same shape. Well, AB goes up 1, 2, over 1, 2, 3, 4, 5, 6. Up 5, or up 2 over 6. Up 2 over 6. So its slope is 2, 6, right? Up 2 over 6. So my point D has to be up 2, 1, 2, over 1, 2, 3, 4, 5. Has to be right here, point D. And if I create my segment, those two lines are congruent. Okay, let's erase color here. Perfect. Now let's create this parallelogram from AC. Is that congruent to BD? Yes, it is, right? It is up 1, or up 2 over 1, up 2 over 1. Okay. Now, is the quadrilateral a parallelogram? Well, we know that opposite sides are congruent, so that's good. We know that they're parallel because they have the same slope. Right? What about the angles? Because we know something about the angles, right? You know that opposite angles are congruent? That's fine. Angle A is 135. How about angle D? Angle D is 135. Good. Well, how about angle C? Angle C is 45. And angle B is 45. Good. Opposite angles are congruent. We know that. Hey, yes, this is a parallelogram. Is a quadrilateral parallelogram? Yes. Justify your answer. Opposite sides are parallel. Okay, that's a parallelogram. Opposite sides are parallel. Take parts A and B for several other quadrilaterals. Not going to do that. If you guys want to, you can. I'm not going to. Part D asks us to write a converse of your conjecture. Is a converse true? The converse is if a quadrilateral is a parallelogram. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay? If a quadrilateral is a parallelogram, then its opposite sides are congruent. Is this converse true? Yeah, right? If something is a parallelogram, there is a parallelogram, then its opposite sides are congruent. We just proved that. We just proved that in our GeoGebra. So is this true? Absolutely, 100% yes. Okay, congruent. Remember, same size, same shape. Construct any quadrilateral whose opposite angles are congruent. Is the quadrilateral a parallelogram? Okay. So, let's make this, well, you know what? Let's just drag this parallelogram. Let's make it something else here. Okay, opposite angles have to be congruent, right? So if that's 121.6, this has to be 121.6. And that's 65.7. This has to be 65.7. See if I can get it here. Ah, close. Anyway, no, not gonna do it. Not gonna mess around with it. Do we know that opposite angles of a parallelogram, they have to be congruent, right? Write the converse. Converse here. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Sorry. And its opposite angles are congruent. Is this true? Is this conjecture true? Yes, 100%, right? I didn't have to make that quadrilateral. I didn't have to make that parallelogram because I knew that its opposite angles had to be congruent. Part 3 here. How can you prove that a quadrilateral is a parallelogram? How can you prove? Well, you can do what we just did. We can show that its opposite sides and angles are congruent. Is a quadrilateral on the right a parallelogram? Explain your reasoning. Yes. Why? Its opposite angles are congruent. I'm going to check my work here and make sure. Okay. Yes. This is a parallelogram because its opposite angles are congruent. In your own words, you can write this, a diagonal. Okay? Diagonal. Diagonal goes from one vertice we'll call one vertex. One vertex to a I'm going to say non-adjacent vertex. Okay, so a diagonal goes from one vertex to a non-adjacent vertex. Parallelogram. Parallelogram. Opposite sides and angles are congruent. Again, these are my words. If you want to write your own words, go for it. Here is a 7.7 theorem, parallelogram, opposite sides, converse. If both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. Okay? If its opposite angles are congruent, then it is a parallelogram. This one here. If the opposite sides, if one pair of opposite sides of a quadrilateral, just one pair, we only need one pair, those are congruent and parallel. Congruent, parallel, then the quadrilateral is a parallelogram. Parallelogram, diagonals converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay? Here's some ways to prove. That's good. Let's get down to business here. State which theorem you can use to prove that the quadrilateral is a parallelogram. Number one, we have A and A. Those are parallel sides. So which theorem can you use? Let's go up here. You can say opposite sides, parallel, and congruent. Okay? Opposite sides, parallel, and congruent. Okay? How about number two? Opposite angles are congruent. Okay, opposite angles congruent theorem. Number three, you have to go up. I have to look, what is the diagonals one? Because I don't remember. I have to quick remind myself. Parallelogram, diagonals, converse. So it is the parallelogram, diagonals. I'm just going to say diagonals, converse. When we get into proofs, it is important that you say parallelogram, opposite angles, congruent theorem, or parallelogram, diagonals, converse, or parallelogram, opposite sides, parallel, and congruent theorem. Okay? It's important to say parallelogram when we get into proofs. As of right now, I'm okay with you guys just saying the diagonals or the opposite angles. I'm okay with that. 4 through 7. Find the values of x and y that make the quadrilateral a parallelogram. Well, in order to make the quadrilateral a parallelogram, this angle and this angle have to be supplementary. And they have to be supplementary. So 3x plus, 3x minus 20, that's not a plus. 3x minus 20 plus x plus 40 have to equal 180. Doing the math, we get 4x plus 20 is equal to 180. We get 4x is equal to 160, and then x is equal to 40. Now, what does y equal? We don't know. We don't know what y equals yet. We know that x is 40, and we know that this angle and this angle have to equal each other. Right? So 3x minus 20 is equal to 4y. Throw 40 into my x, so I get 3 times 40 minus 20 equals 4y. 3 times 40 is 120. Minus 20 is equal to 4y. 100 is equal to 4y. Y is equal to 25. A lot of math involved there. But we did it. We accomplished our feat. We accomplished number 4. Number 5. What do we know? we know that this side has to be congruent to this side. Okay, the diagonals have to be congruent. We know that this side has to be equal to this side. Let's start with y. Okay, 2y is equal to y plus 1. Well, y is equal to 1. Let's start with x. We have 6x is equal to 4x plus 10. Subtract 4x, we get 2x is equal to 10. And then divide by 2, x is equal to 5. Y is equal to 1, x is equal to 5. That one was a lot quicker than the first one. That should have been our first example. Number 6. We know y, right? Because the opposite angles have to be congruent. We know that y is equal to 106. Hey, we got one down. What do we know about these opposite sides? They have to be congruent, right? So 10x plus 7, that's my one side, has to be equal to 12x minus 9. That's my other side. Okay, manipulate this. I get 16 is equal to 8x. Divide by 8, I get 2 is equal to x. Last one. Again, opposite sides have to be congruent. Okay, so 5x plus 16 has to be equal to 6x minus 1. Okay, so 17 has to be equal to x. That one was quick. Y's, we know that 70 has to equal 4y plus 2. Okay, if I subtract 2, I get 68 is equal to 4y. Now I need my calculator because I forgot what 68 divided by 4 is. Actually, I'm just going to do it the good old-fashioned way up here. 4 goes into 6 one time, left with 28, so I know that. Hey, no, not 14, holy cow, 17. Bad math by me. 17 is equal to y. Okay, that is 7.3.